down monthly pricing and a fully turnkey scanner program. Ori ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today. Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line Ori 3.0 intraoral scanning system without buying any inventory. Ori offers lab owners $0 down monthly pricing and a fully turnkey scanner program. Ori ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today.
Hello everybody, I'm excited to see you in Chicago, and I want to talk today about the new Argen Z GT. Give you a little sneak peek of the product that's coming out right now, currently in beta. The Argen Z GT marries the best of both worlds with a 4Y and a 5Y zirconia. So the Argen Z GT has 1250 megapascals in the gingival area, 1250 megapascals in the middle where your bridge connectors are, and over 1000 MPa in the transition layers as we get in the incisal. The incisal is 850 megapascals, giving you a 50% translucency in the areas where you need it. So you get the strength where you need it and the aesthetics where you need it. With the Argen Z GT, we have a patented smart gradient technology, which gives you micro mamelon effects in each layer, which reflects light more like natural teeth.
Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line ORI 3.0 intraoral scanning system without buying any inventory. ORI offers lab owners $0 down monthly pricing and a fully turnkey scanner program. ORI ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today.
What exactly is smart gradient technology? Stay tuned as we discover the answer together. Let us begin with a common multi-shade disc. I've seen them, you've seen them. Indeed, they are everywhere. But how are the layers arranged inside? Let us open one up and see for ourselves. Here we see where a future dental unit will be placed. But we still require those multiple layers. Let us add them now. There we go. That is quite professional. But wait, aren't those lines a bit harsh? Let us look closer. Oh dear, they are very harsh indeed. We simply cannot have that. But does this affect the final product? Behold, this is a photograph of a competitor's disc. Oh my, look right here, and here. That is certainly not the Argen standard. There must be a better way. Wait, doesn't Argen have a superior plan? How can Argen possibly improve upon this? Let us observe what Argen does to these layers. Well, look at that. They have blended them to more closely mimic nature herself. Isn't that something? Now, when sintered, we achieve a marvelous natural blending of these layers. Fantastic. This structure exists within the tooth, not merely as a surface variation. The result? A natural-looking translucency, just like, well, nature. Argen ZGT is precisely what you require. It possesses marvelous strength and truly smart gradients. Let us take a final look at these layers to see what makes them so intelligent. Observe, Argen has placed the layers exactly where they are needed most. We find great translucency at the very tippy top of the teeth. Yet just below, the material grows stronger where the connectors reside. At last, we can have everything we need. The versatility of ZGT. That is very helpful in keeping things strong indeed. But you may wonder, is this disc suitable for every indication? Let us investigate. First, let us look at a simple crown. The properties of Argen ZGT make it ideal for those aesthetic cases traditionally reserved for Argen ZSTML, 5Y zirconia, or even lithium disilicate. Now, you can simply utilize Argen ZGT and be confident that your crowns will be simply beautiful. Now, what about those tricky bridges? Bridge cases benefit from aesthetic beauty and translucency in the incisal gradient without sacrificing strength in the connectors. Argen has you covered. And what of the full arch? These too benefit from that same beauty and translucency, while the transition zone is strategically placed to allow for even the largest of arches. So, for crowns, bridges, and full arches, Argen has precisely the disc for you. And tell me, why carry such a cumbersome variety of discs in different strengths and thicknesses? Simplify your laboratory and carry only Argen ZGT. It truly is the disc you've been looking for. Argen Z, better than your mother could make. That is, unless your mother works for Argen.
Hi, I'm Beth from Argen. Join me and Pam. We're going to talk about how to bridge RPDs in today's digital world. Pam's going to be talking about the theory, and then I'll be talking and showing you about the design process in 3Shape. You don't want to miss it.
Good morning. Thank you for joining us. My name is Stephanie Dahl, and I'm a director of sales for the Western United States for Argen. And thank you again for joining us. I wanted to share with you that Argen is right now in this particular presentation is the first ever live stream event for all of LMT. And so for those of you joining us online, thank you. Please be sure that you pre-register in our YouTube channel in the Eventbrite section so you can get your CE credits. And also, please like and share this information with anybody else who may not be able to attend. Before we get started here, I have the pleasure of introducing both Beth and Pam. And I'll tell you, between Pam in Canada and Beth in the United States here, we've got North America covered really well. So Pam is our National Director, Product Director in Canada, and I'm sure many of you have heard her speak before. It's just a true wealth of knowledge. And Beth is our Senior Trainer and Technical Advisor at Argen, and you've probably seen her online if you go on to argen.com and our education. Many trainings and webinars that both Pam and Beth do. So I am so happy to and honored to introduce both of you, and I'm going to turn it over to you. Thank you.
Hello.
Hello.
Thank you, guys. We're both really excited. I'm really excited. I've always wanted to do a lecture with Beth, so I'm super excited to be here. So we're going to kind of go back and forth a little bit today. I'm going to talk a little bit of theory, and then Beth's going to come online and show you guys how to actually click the buttons in 3Shape. And we're going to share the space a little bit so you're not just watching all of one thing and then all of another thing. So I'm going to start here with a little bit of background, and then I'll toss it off to Beth when we're ready to go. All right. We're talking partials. Does this work? Yeah, we got it. Okay. I wanted to start with some industry statistics. Now, these are from Canada because I am Canadian, but I know that how we're seeing the industry trends are very much the same with the U.S., and actually the U.S. typically sets the trends, and Canada is close to follow. So these are real statistics that we pulled, and basically it's showing that year over year, the Canadian dental market for dentures and partials is rapidly growing, and we do have an aging population. Now, we only have about 41 million in our entire country. You guys have more in the state of California, so I'm sure that your population is also aging rapidly, and you are also seeing a lot of partials and a lot of dentures. In Canada, the Canadian Alliance of Dental Technologists, we actually launched a federal program to try to initiate the critical shortage of dental technicians in Canada. And I know you guys are facing a very similar shortage. You're having challenges finding qualified technicians. So what's happening is we are losing knowledge, but we are gaining patience. Some of the best technicians I know are retiring, and they're not passing down their knowledge. So our goal today is to try and reignite some of those ideas. We only have an hour, so we're realistically not going to get into the real weeds with partials, but we're going to do our best. And then at the end of this, I'm going to show you some resources where you can go read some books, find some YouTube channels, so that you can really like develop your skills. So, what are the manufacturing options? We all know our manufacturing options. There's 4 main options. We can do analog, printed wax cast, we can mill a framework out of a milled disc, and the most popular and the one that's growing the most right now is SLM printed. And the reason why it's growing typically is because material costs can be kept low, and it's a lot more efficient than a lot of these other options. And I know you're thinking it's not as good as an analog framework, but there was actually a study done, and it was based off of 967 different papers. So a whole bunch of studies were distilled into one study to really analyze the benefits of a printed partial over an analog partial. And what they found, and you'll see in this chart here, everything in the dark orange is the SLM print, and everything in the yellow is your conventional cast framework. And so again, this is over 967 different studies. So a whole bunch of small studies were combined into one evaluation, and they found that an SLM 3D printed partial fits better in all areas, around the rest seats, across the palette, and in all areas in general. A printed partial has a better fit than an analog framework. So we're removing some of that human error, and we're definitely removing the manufacturing. I don't know if any of you have manufactured a partial. There's like 25 steps involved. It's very time consuming. It's very, very, very labor intensive. So if we can remove some of those barriers and make this a little bit more easy to access, then the only knowledge that we need to have is the design. We don't need to retain all of that knowledge of manufacturing because the manufacturing process has changed a lot. Training somebody to manufacture a partial is going to take years and years to really get a good partial frameworks technician. But training someone to design a good partial, you can do that in a very short amount of time. And you don't necessarily need to manufacture your own partials. That's where Argen comes in. We are a manufacturing facility. And so we're here to support your labs so you can have your own designs, send them to us, and we can manufacture it for you. What is SLM printing? I mean, at this point, you all kind of have a general idea, but it's a powder, you have a laser, and then the laser is heating up the powder layer by layer by layer and basically melting that powder into the shape of your framework as it builds up. So let's talk design. So like I said, we're going to talk theory. I'm going to go through each part of the partial. I'm going to pass it over to Beth. So we're going to start at the very beginning. Hang on. Oh, no, we're not switching over to Beth yet. Switch back for one moment. Thank you. We're going to start with the survey and blockout. So this is the most important part of your partial. Surveying and blocking out. You really are setting the stage for how everything's going to be designed, how it's going to fit in the mouth, and you really want to make sure that when you're blocking it out correctly. And so it's actually easier than we think. We all remember these surveyors. I said in one lecture, if you're old, you remember these. Okay, we still use them. We're not old. Everybody calm down. We're still actively using them. And in 3Shape, we have all the same tools. So we're able to see the same information. It's just being presented to us a little bit differently. So when we're looking down the model, straight down, as if we were on our surveyor, that's what that arrow is in 3Shape. And that's how we can kind of correlate the two things between our analog knowledge and our digital workflows. And when we're looking at the undercuts in 3Shape, I found this little guide. It's a little blurry, my apologies. So when we're designing a metal framework, you really want to have your undercuts engaging in the yellow area. If you're designing acetal or PEEK, you want to have it engaging in the orange area, the light orange. And if you're doing like a thermoflex, you would want it in the dark orange area. So now I'm going to pass it off to Beth, and she's going to show us all the way up to that point in 3Shape.
Yeah, so we're going to start really from the order form. The order form in 3Shape is very simple. You're going to select your arch, and then you come down to removable. Okay, and then you can pick your materials as normal. If you're using Argen, it definitely is important to choose that Argen RPD to get the proper parameters. And we offer finished and unfinished. So this would be your basic order form for standard RPD framework. If you're adding teeth or want teeth to be part of the partial, like metal backings or whatnot, then you're going to add a pontic to the order form in that tooth position. So your standard crown pontic. If you're wanting just a dummy tooth in position, then you're going to choose artificial tooth, okay? But for today, we're just going to go over the basic framework. I'm going to go ahead and cancel this. I have a case ready for us. And we start at the prepare step. So if you need to do any preparation to your scans, the prepare step is where you do them. And we're going to move forward to the surveying and blocking out. So on the left-hand side, down here at the bottom, you have a block out angle. And if I go to preview, it's going to block out your model based on that insertion path. So I'm coming 3 degrees out from that first point of undercut. But if you need to change the insertion, you can do it a couple different ways. You can do it based on the way you're looking at the scan, and you just set it on the left, or you can move the insertion a certain degree of direction with these arrows. So you can type in, let's say, 5 degrees and move it in that direction. And these 3 boxes down here give you an easy view of all sides of the arch without having to rotate your scan, right? So if you set it, you can see that the coloring will change. And let's preview again. We'll get that 3 degrees of block out. And then when we get into the next step, that's when we'll start customizing for what kind of partial we're designing, whether it's the flexible, whether it's metal framework. And you're going to use your standard sculpt toolkit for that. So if I want to remove or smooth, I would remove this into the yellow. You can also add specific block out. If you want to add or remove a specific number, you can do that down here with this setting. So if I say I want to add 4/10, I can start adding, and it will stop adding or removing when it's reached that 4/10 from the scan. Okay, so it works with adding or removing that function. And that's up to survey and blockout.
Sweet, we'll switch it back and we'll talk about some of the major connectors. So this is just going to be a really brief overview. I do suggest if you're getting into design, like I said, I'll have some suggestions at the end to do a more deep dive. But some of your basic numbers here, if you're doing an AP strap, you want those pieces to be 6 to 8 millimeters, and you need 15 millimeters of space between each one. If you're doing a palatal strap that goes across, you want it to at least be 8 to 10 millimeters thick. Anytime you're doing a major connector, you want it to cross that midline at 90 degrees. You want it to cross all your gingival margins at 90 degrees. And you want to avoid any sharp or rigid lines. So you want it to be nice and natural curves, because otherwise the tongue is going to feel that. I don't know if you have like a wire on your lower, like a lower brace. A lot of people have those, and your tongue is just constantly playing with that. And it would be the same with a partial. So we want to try to make it natural curves, natural waves, so that it doesn't feel so intrusive in the mouth. For the lower, all of those ideas still stand. You want it to cross the midline at 90 degrees, cross your gingival margins at 90, avoid any sharp things. Your pear-shaped here is a lingual bar, okay, and it's always going to be pear-shaped. In 3 shape, it's already pre-made for you in that shape, and it's already going to be pre-blocked out for you. What you need, though, so from the top of the gingival margin to the depth of the sulcus, you need a good 8 to 10 millimeters of space. And so not everybody's mouth has that, and so that's why you would switch over to a plate instead. And the plates can act as an anti-rotational stop, so you don't have to have like cingulum rests necessarily, because they're acting as the rest. We're going to talk about that a little bit further down the line when we talk about some of the functions. So I will toss it over to Beth, and she's going to do one of the major connectors on 3Shape.
Yeah, so in 3Shape, on the left, it works from the top down. So you start with retention grids, and this drop down gives you different options of retention grids. And you have to click on the icon here to start applying the retention grid. So it gives you the pencil, and then in the RPD workflow, if you notice there's a small circle down here, that's 3Shape's way of indicating what kind of spline. So it wants a full circle, so we're going to connect the first point and the last point together to complete it. One of the things in the RPD is the preview button is going to be your best friend here, because you don't want to get all the way to the end of the workflow and then have to work your way backwards all the time. It's very time consuming. So the preview is there. Let me go do the other side and I'll show you some different functions for changing the retention grid, changing the resin gap. You can also rotate the design of this. So if I have my retention grid here and I click on the circle one time, it now gives me this function, and I can move those holes or move the position of them if I want to. I'll go to preview again. You can also change the resin gap here. Let me get in there. Oh, I did it to myself. So your resin gap is down here on the bottom left. There we go. So I activated it. Now we can see this green line coming around our resin gap. And if I hold shift and work on my scroll on the mouse, then I'm adjusting that resin gap, okay, or the position of it. You just have to remember it has to be active, so the spline is yellow, so you can see that green and make the adjustments. Correct. So you have the different options with retention grids, and as we move forward to the major connector, you'll notice here with the icons, so we have a circle, which is a full circle, and then we have the straight line. So when you do the straight line, you don't have to do that full circle, depending on the tool that you're applying. So I'm going to go ahead and activate the major connector. And the key here is it has to intersect another part of the partial design. So in this case, we're going to overlap across the retention grid, as it wants to connect those parts. We'll just kind of crumb across. And then you also have your associated settings over here on the left that all apply to the thickness of the partial. And of course, with the digital partials, you want them to be a little bit thicker to survive manufacturing, right? There is some expected finishing to happen once it gets into your lab, okay? But like anything digital, you have it a little bit thicker so it can survive that process. So here's our major connector. We can also add windows here. If you want to add a palatal window. Preview again. There's a couple different places or two different steps for occlusal rests. Here is one where you're drawing the full circle, but I'll wait till we get to the class to show you that one. That will really come based on your preference, right? You try both of them. Which one do you like? Which one do you have to work less on? There's a couple different options. You also have a relief zone here. This is a spline that's allowing a relief zone based on this setting. You can either block out like we did in the wax knife and the survey and blockout step, but you can also add another relief zone with a spline here and a setting. You would just activate it and apply it where you need it, and then it would apply this 0.15. Okay. If you need to make any adjustments, you can also right-click on the spline. You can delete it. If you are a fan of the fast edit, you can activate that, and then you just click and make that adjustment. Okay, but if I need to make any adjustments to the retention grid, I'm moving back in the workflow. Okay, and then preview is always a good idea because you don't want to get too far. The other thing to note here about the RPD design workflow is there's no undo redo button like in most of the workflows in 3Shape. Okay, so just keep that in mind. So you can see here it's having some issues. And if you continue, I'm going to delete. Yeah?
Quick question. So palatable thickness is a combination of the two. If you get your major connector there,
Mm-hmm.
your substructure and your wax thickness.
Correct.
So right now your major connector is from 7.
Correct. And the minimum thickness for Argen's SLM production on RPDs, the minimum is the 0.7. So if you're designing and you plan to do any smoothing or adjusting in the design, you might want to start off a little bit thicker. I'll just do a rough little outline here, see if it calculates for us.
We can switch over if you want, Beth,
Okay.
and then you can make it work.
Yeah, we'll switch back to Pam.
We'll
and then I'll
switch it
get this
over, and
fixed.
then Beth will get it fixed on her side, and we'll move on to the next steps here. Okay, so this is where a lot of people, when you're learning about partials, you're learning it in school or someone's training you, this is where your eyes glaze over. So I'm going to try to make this as brief and as interesting as possible, but this kind of goes into the foundations of a clasp design. We need to understand how a fulcrum works when we're talking about a clasp design. So this is just a teeter-totter. You have somebody sitting on this side, that's the force. You have some resistance, we have more force than resistance, it moves up, okay? Make sense, teeter-totter? How does this apply to partials? So when you have your force is chewing, is eating, is talking, your tongue is moving it. Your fulcrum is always where the rest is, okay? Your rest seat is always the fulcrum point. And your resistance is the clasp that's holding onto the tooth, right? So this is only applicable if we have a distal free end or a free end in general. This is not applicable, so if it's going up and down, you can see it's going to be moving. If you have a case where it's tooth-borne, there's no fulcrum because there's nowhere for it to move. It's going to sit on those rests, and it's not going to go up and down, right? So in a typical situation, so this is our canine, we have a distal free end, we want to do a C-clasp, and you might hear like, well, we can't do a distal rest. You never do a distal rest. Well, why? This is the why, okay? So right where that distal rest is, that becomes your fulcrum. And you can see as the thing moves down, because that's the fulcrum, the pressure is moving up. So now we're putting pressure up on that tooth every time that it moves down. We don't want that. Now we're going to be torquing that tooth every single time. So if we instead move that rest over, now we have a mesial rest, and we have an I bar, so the undercut is being engaged before the rest. When we move it, the clasp moves with it because it's on the same side as the fulcrum. So the clasp and the function are moving together, and we're not torquing that tooth. That is why typically on a distal free end, you want to have a mesial rest, because you want to make sure that your clasp tip and your edentulous space are on the same side. Your undercut and your edentulous space are on the same side. So this is a really brief overview. I'm going to try to go through this part a little bit quicker of rest seats, because this is more for your dentist to understand, but it's nice to know as a lab. It's nice to kind of send them this information. So this is going to be some of the basics of what a rest seat should be prepped like and what it should look like. So we have 3 different rests here. We'll start with the occlusal rest. So typically you want it about half the width of the intercostal space, half of the mesial distal width of the tooth. It has to be a positive direction. So it has to be going down into the tooth so that when the rest is seated down, it's not sliding off that tooth. And you want it to have 1.5 millimeters of clearance so that you can have, you know, your whole clasp arm coming up in there, or there's not going to be enough space. For embrasure seats, it's very, very similar, but this is really important, that channel. I don't know how many of you have made partials, but you very rarely get a channel and you're trying to squeeze in an embrasure rest and there's not enough space there. So I usually emphasize that to my dentists. Make sure they're prepping that channel, otherwise it's not going to work. And then the incisal rest is very similar. Again, you want to make sure that it's coming down at a downwards angle. Again, these are more for our dentists to understand, but it's nice for us as a lab to know these measurements so we can give them some guidance if they're asking questions. Or even if they're not asking questions, it's still nice to give them guidance sometimes. Okay, so that brings us to our clasp assembly. Each clasp consists of 3 things. Every time you have a clasp, you should be considering what are the 3 things. It should have a reciprocating arm, it should have a retentive arm, and you should have the rest. Now there's a lot of different types of clasps and you'll see them in different kinds of ways, even like things like an I-bar or a T-bar, they usually have some kind of a rest associated with it as well. So you always want to have these 3 things. And there's some elements in the design to what types of clasp we want and what types of design elements make sense with it. So if we have a uniform thickness clasp, that is the same even everywhere, then it's going to be really rigid. If it's a tapered clasp, then it's going to be flexible. If it's a short clasp, then it's going to be rigid. If it's a long clasp, oh, I'm clicking too fast here, then it's going to be flexible. And if it's a thick clasp, it's going to be rigid, and if it's a thin clasp, it's going to be flexible. So there's different aspects that we want for different types of clasp. Sometimes we want a rigid clasp, and sometimes we want a flexible clasp. So where do these 2 types of clasps come into play? If we imagine this is our tooth here and that is our height of contour, then when we're going to draw our clasp, it's going to come down the height of contour and it's going to engage underneath that height of contour, right? And if we were to look at it at the side, every time that clasp comes over, we're putting force on that tooth because we're engaging that undercut, so we're pushing it. And it's going to twist that tooth every time that we're pushing force down on it. Because we have to put force on this tooth in a downward motion to get around the undercut. So if we're trying to get around an undercut, we want it to be flexible. So then we probably want it to be tapered and long and narrow because we want it to flex as it comes around the undercut. But also, we need to reciprocate that force. We don't want to just push that tooth out of the way. So if we're looking down from the top, we have our engaging clasp arm, we have our rest seat, and then we want something to balance out that force so we're not pushing that tooth. And that's where your reciprocating arm comes into play. And for your reciprocating arm, it's not going to engage the undercut. It's just going to sit there and not move and be rigid. So if we want a rigid clasp, we want it to be wide and short and thicker and go up above where the undercuts are. So one side is engaging, one side is stabilizing. And all together, this makes a clasp assembly. And if we're looking at an anterior tooth, it's very similar as well. So we would have our clasp in the front. This is an I-bar, and it's going to engage in the front. And so what we have to have on the other side, instead of a reciprocating arm, we would have a reciprocating rest. So we would put a rest there, and that acts as the rest and the reciprocating force to hold it so that it's not flexing every time we go around that undercut. So it's kind of doing 2 things at once, but it still has the clasp, the rest, and the reciprocating arm. It's just 2 pieces are in one. So that's kind of the functional idea behind the clasp assembly. And when we're actually going into design, here's a little bit of guidance around that. You want the top part of your clasp to be rigid, coming down to a little bit more flexible. So where it's engaging that undercut is going to be flexible and be tapered. The minimum thickness that we're kind of suggesting for a printed SLM framework is 0.9 millimeters because like Beth said, it does have to go through processing after it's been designed and manufactured. The reciprocating clasp, you want it above the yellow. We don't want it to engage at all, and you typically want it to be a nice, even thickness because this is holding things in place. It's not going to flex over an undercut. And then same with an I-bar design. You want to engage that undercut about 2 millimeters. Same minimum thickness. You don't really want to go lower than a 0.9 I know that our guidelines say 0.7, but that's pretty thin. If you're getting to that 0.7, it might sharpen up a little bit after the processing. So 0.9 is a nice way to be at. And like I said, there are hundreds of different names for clasps. So you'll see a lot of different prescriptions with a lot of different names for clasps, like a roach clasp, a G clasp, all of these different things. But they all have the same thing in common. They all have a rest, a retentive element, and a reciprocating element. The last thing I'll talk about before I let Beth finish the design here is the minor connectors. So that's how everything connects to each other. And we talked about a fulcrum on the tooth and how if we go up and down like this, we don't want pressure on that tooth. There's also a fulcrum across the entire arch. So this is two distal free ends. Let's see if this works here. There we go. So if I'm going to do two eye bars and I have my rest there, my mesial rest, if I go through both of the rests, it's going to rotate on that spot. That's where, as they're chewing and eating, it's spinning where both those rests are. So if we draw a line perpendicular to both of those rests, we want to have something balancing out those forces. And that is where you're going to have anterior rest seats. Now, if you're doing a plate, that would be your anterior rest seat. But if you're doing a bar, you want to have something in the anterior. I recommend trying, if you can, to get them on the canines or the first premolars because the roots are a lot deeper. They're going to be more stable. If you're going to do them on a lateral, it's at like a last resort because it could push those out. Like canines are typically your best bet. And then from there, you're going to have all of your minor connectors. That's basically everything that's connecting down to your main partial. And you want all of those to always cross your gingival margin at that 90 degrees. And you want to make sure that there's no sharp corners, like round out all the corners where you're making your connections. And then you would have your lingual bar like this. Just like that. So you want to have it nice and cornered like that so we don't have any sharp edges, rounding it out, always crossing that gingival margin at 90 degrees. So I think I'll pass it back to Beth. She'll finish the design, and then I'll have some closing remarks after that.
Okay, so on the left here under the clasps, you can see here you have the minor connector, and then you have a clasp menu. Depending on what you select in your clasps will determine how it's applying, but you always have the option to modify it for the tapering or thickening that you need. So if I just choose occlusal rest, and you'll notice that the spline here is just a single line. So depending on where you're going, again, I'm intersecting that retention grid and then it just applies it, okay, when I double click on that last one. If I need to make adjustments to this, and this applies to all of the clasps in 3-shape, if I hold my shift, and I'll zoom in a little bit, it's giving you an active measurement, and then I can use my scroll to either thicken it or thin it out. If I hold my control, it's going in a different direction. So you can make the adjustments both ways, and you can do that on every clasp. You can also move the points, you can add and remove. You'll notice here how this has a slight fold. We can also adjust that with our wax knife, okay, when we move forward at the next step. So if I want to activate another option or do another clasp, then I'm going to activate my pencil and then apply it and make the necessary adjustments. If I come down to a different selection, let's say a jumper. Oh, I switched that one. Let's go back. It was active. If it's yellow, hold on, it's active. There we go. Let me switch it back. Jumper. Right, and then keeping in mind, you can see that I'm still pretty blocked out. I didn't spend a lot of time going over and removing some of those blocked out areas. And then if I choose different ones, there's a uniform in here. My design's a little rough. And if I hold my shift, this is almost 2. Pretty consistent all the way around. Pretty uniform. It doesn't have that taper like some of the other ones. But again, you can always increase or decrease, and you can see how the shape is being applied. So you have your different clasps, your minors, and a whole menu in there to kind of play with. And then when we go next, when we get into the sculpting, that's when we can kind of smooth things out, use our wax knife. You just want to be mindful, and you might have to do manual measurements with your 2D cross section to really dial in that thickness, right? Make sure you're thick enough in all areas. And then if I wanted to smooth, I can definitely come in here and do that. Okay, with your standard wax knife settings. And then when we get into finishing line, they have a drop down for, you know, Argen has one for upper and lower. There's also one for standard and wide, but just remember you can always change the thickness. So if this is applied, the other thing is if it's counterclockwise, we'll put it in the correct position. I think it's counterclockwise. But you can see how this one is upside down. So you just right click on the spline and reverse it. And it'll put it in the right direction. And then as we go forward, you can do stippling at the end of the workflow in the finalize. You can also add your tissue stops and different attachments that you might need. So wax knife here, attachments. Once you apply the attachment, you have the option to rotate. You can make it taller or smaller. If we go over to the stippling here, you can apply it to the entire surface by the check mark, or you can select the surface. Okay, and then there is a protected area that it's not going to cross over. I'll just do half. And you also have a drop down here on the different options as far as your stippling. And then the height of that stippling.
Is there one of those that works better with the SLM process than others?
I don't have an answer to that as far as works better.
Maybe less aggressive.
There's definitely the settings here would apply the aggressiveness, right? So we're at 500s. If we were to increase that, this would be much more extreme. And you have different options to come down here and choose from as far as the design of that stippled wax. And then we also have the option here to complete an ID tag. So for those of you that might be in areas where it's actually legally required to do an ID tag, you can do that on any of the surfaces. And you also have the depth here, right? If it's a negative, that means it's an engraved ID tag. And then you also have control over the height. So I'm just going to go ahead and kind of click. You can place it where you need to. You can also click and drag it wherever you need to. And then you would click the apply to see it actually applied. And then as we move forward into the pre-manufacturing, you can add support bars here and whatnot. Of course, when you're sending to Argen for production of RPDs, you don't need to add any of the support bars. We do all that in-house. This is the place where you're going to apply the tissue stops. All I have to do is click on it. You have to activate the pencil every time for every tissue stop, and then once you go to preview, you'll be able to see that actually applied. Okay, and you can see the tissue stops. We can also run measurements with our 2D cross section. And click wherever you want to perform that measurement. And you can see at this, we're just shy of 9/10. Okay, but paying double attention to the edges is always a good idea. We tend to see kind of thinness happening around the edges, and that won't survive manufacturing. So just make sure that your partials are definitely thick enough to survive that. And for design, that's it. And then you generate your cam like you would for any other case, the same way.
What did you end up having to do to stop the error?
I deleted the major connector and reapplied it. I think somewhere it got confused with the fast edit. Maybe some points were kind of overcrossing, but yeah, I just deleted it and kind of reapplied it. Yeah.
If you had that situation because of a hole in the sand, I guess in the beginning when you're doing the first step, I forget
The preparation step.
Yep. Yeah.
your only option at that point,
Yes.
the refine.
Well, the refine will refine the scans as a whole. If you have a large hole, it may not close it, but you also have this remove artifacts. And if you have a small hole, you can actually draw a circle around it and then click the apply and it will close the hole. Okay, you can also do tooth extractions in the prepare step. It all really depends on what you have. Have you already scanned the model and you don't want to rescan it or make adjustments, then the prepare step is there for you. And if it's a digital impression, that's the only step you have to modify the scans, is in the prepare step. Okay, so that's all there for you, but yes, at the beginning of the workflow. And in the newer versions of 3Shape, the refining is now present for model cases. So it's not limited only to digital impressions, it is there for models as well.
Thank you, Beth. We will switch back and I'll wrap it up for us. So, like I said, this was just a really initial step into this. If you really want a deep dive, I'm going to share a couple of resources here. First is our education page. So if you want to watch the YouTube videos or watch our webinars on click-by-click instructions with Beth and Tom, honestly, that's the best place to go. As far as books go, these are the 4 that I referenced. This is what I learned from. That top red one, I call that my partials Bible. I reference everything from there. It's a really, really good resource. You can buy it on Amazon. They're all slightly different versions of each other with slightly different theory, but it'll give you a good idea. And then I put this YouTube channel in here. I don't personally know this person, and I hope that one day we can meet, but this is one of the best YouTube channels for all things partial designs. The way that he's developed his videos is very, very helpful and helped me a lot in putting together this presentation also in the past, because I haven't made a partial in a little while, so I had to have a nice refresher, and it was a good page for that. So these are my go-tos, and this wasn't as in-depth as it could have been. We could spend 5 days talking on partials, so we only had an hour today, so I hope that we were able to pass along some information and get you guys excited and maybe just thinking about some of the ideas around RPDs. Beth and I will be here in the lounge, and we'll be answering some of the live stream questions. We'll be typing in there after this, so if anybody has questions, please stay and ask, and we're happy to be here. Thank you guys so much.
Thanks, everyone.
Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line ORI 3.0 intraoral scanning system without buying any inventory. ORI offers lab owners $0 down monthly pricing and a fully turnkey scanner program. ORI ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today. Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line ORI 3.0 intraoral scanning system without buying any inventory. ORI offers lab owners $0 down monthly pricing and a fully turnkey scanner program. ORI ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today.
Hello, everybody. I'm excited to see you in Chicago, and I want to talk today about the new Argen Z GT. Give you a little sneak peek of the product that's coming out right now, currently in beta. The Argen Z GT marries the best of both worlds with a 4Y and a 5Y zirconia. So the Argen Z GT has 1250 megapascals in the gingival area, 1250 megapascals in the middle where your bridge connectors are, and over 1000 MPa in the transition layers as we get into the incisal. The incisal is 850 megapascals, giving you a 50% translucency in the areas where you need it. So you get the strength where you need it and the aesthetics where you need it. With the Argen Z GT, we have a patented smart gradient technology, which gives you micro mamelon effects in each layer, which reflects light more like natural teeth.
Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line ORI 3.0 intraoral scanning system without buying any inventory. ORI offers lab owners $0 down monthly pricing and a fully turnkey scanner program. ORI ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today.